Feel free to listen to that if you're interested. Anyway, we're here to talk about this task today. This is quite an infamous task, actually. If we take a look at it, I just want to draw your attention to one thing first. So if we look at the solutions here, 14,429. So that's a lot of solutions, but when we compare it to, for example, the previous one, whoa, that's like double the number. So people are kind of getting a little hung up on this one. They're getting stuck on this one. And maybe we'll find out what that is, what the reason for that is. We'll see. But first, before we get into that, let's see what the question's actually asking.
Given a sequence of integers as an array, determine whether it is possible to obtain a strictly increasing sequence by removing no more than one element from the array.
Okay, so we've talked about arrays before. We've done some work with arrays for sure. What's a strictly increasing sequence? Well, basically we're talking about a sequence of numbers that only goes up. So as we go through the array going left to right, are the numbers only going up? So we could look at it in terms of these arrays. I mean, that's sort of how the tests are given, just arrays of numbers. But to make it a little more visual, we could sort of think of these on a Cartesian plane, sort of like a scatter plot, something like that. So I've drawn these in advance. So basically the idea is on the left here, what we have is a strictly increasing sequence. You notice the elements are all going up as we go from left to right. Whereas on the right here, this is not strictly increasing. It decreases, it increases and stays the same. So this is not strictly increasing. Okay, so looking at this one over here, if we were to, let's say, add an extra node. So let's put one here. If we put it here, it's still strictly increasing. So this is fine as well. If we put it somewhere like, let's say, here, so now, and let's assume these two are at the exact same height, now we would say that this is not strictly increasing. We could say that maybe it's increasing, but not strictly increasing because it has to actually go up every time if it's going to be strictly increasing. It can't stay at the same level. So it's not enough for it to just not go down. It has to always go up. That's an important detail. But in terms of what this problem is actually asking, notice it's saying it's not asking us to check whether we have a strictly increasing sequence already. It's asking us to check, would it be possible to get a strictly increasing sequence by removing at most one element? Okay, so basically this one, well, this would actually be fine, because if we remove this yellow element, or this one over here, but the point is, if we remove one of these elements, it would become a strictly increasing sequence. So that one would be fine. In fact, it would be fine even if this thing was up here or down here. It doesn't really matter. So basically the idea is that for the one on the left, we should expect true. I mean, this would work. This could become a strictly increasing sequence if we were to remove one of our nodes, whereas this one, we would definitely want to return false, because no matter which one of the nodes you remove here, it's not going to become strictly increasing. If we wanted it to become strictly increasing, we'd have to remove a lot of nodes. So, I mean, for the purpose of this problem, one is enough. If you have to remove one, forget about it. Sorry, if you have to remove more than one, forget about it. Okay, so I feel like we probably understand what the problem is asking at this point. So let's actually talk about how we're going to do the problem. So one way we could do it, just going back to these, is we could say, well, since we're checking to see if we would get a strictly increasing sequence by removing at most one element, well, we could just test this. So, remove this element, for example, and then check if this thing is strictly increasing, and then it would pass. And it probably won't be too hard to write a function that checks if a sequence is strictly increasing. That's probably going to be the easy part, or the relatively easy part anyway. The problem is that we don't know that it's this node in particular, so we sort of have to figure out, well, which one of these is causing the problem. And basically, in order to do that, we'll sort of have to check every one of them. So we'll say, okay, if we were to remove this, would this be strictly increasing? No. Okay. If we were to remove this, would it be strictly increasing? No. Okay. What if we were to remove this? Would it be strictly increasing then? No? All right, what if we remove this? Strictly increasing? Oh, it is. Okay, great. We'll return true at that point. But if that didn't happen, if it was like, for example, this one, and we check this one, check this one, check this one, keep going all the way to the end, and it still doesn't become a strictly increasing sequence, well then at the end, we'll return false. Okay, so that's basically our game plan here. We want to take a look at this, and we basically want to run an algorithm that's going to go through every node in the sequence, and one by one, basically it'll create a new sequence that doesn't involve that node, and then test if that sequence is strictly increasing. And if it is, it'll return true. If it doesn't find any of those, it'll return false. Okay, so let's make some notes here. So we want to loop through sequence, removing one element at a time. Or I guess more accurately, we're actually making a copy of the sequence without one element. That's more accurate. So it's not so much that we're removing one at a time. We're making a new copy of the sequence that's lacking one of those elements. Okay, great. So then after that, check if it's strictly increasing, and if so, return true. If you don't find one, return false. Alright, so that's basically our game plan here. Let's try to follow through with this. So I'll just make a bit of space for us to write our actual code here. And let's get this started. So first of all, looping through the sequence. We're probably getting used to this by now. If we want to loop through something, usually we're going to use a for loop. I mean, we could use other kinds of loops. There's while loops, etc. But we're going to use the for loop. And I mean, like we've seen, there are different styles of for loops as well. Different ways we could do it. Using the in keyword, using the of keyword. So maybe we'll look at that pretty soon, but for now we're just going to do this, and let's see. Well, you know what? Before we go any further, since we don't need I to interact with anything outside of the loop here, since we don't need to worry about what I is going to be after this loop's done, I only needs to exist within the scope of this loop, so I'm actually just going to use a let keyword to declare the I over here. So we talked about this before. Let basically means that the I is going to be scoped to this loop here. So if we try to access the I outside of the loop, not going to happen. Okay, great. So then we could say something like, well, let's see. We want to make a copy of the array that's lacking this one index. Well, I know we've talked about slice before, and we've talked about how we can use that to make a copy of an array, specifically a deep copy of the array. But we haven't really talked yet about how we're going to remove one element. So there are a few ways we could do that. We could do something like this. So let's just get some of this junk off the screen for just a minute. We'll bring it back afterwards. But let's just say return sequence dot slice. Just a little bit of a review on how slice works. We could do something like this, and it'll give us just part of this array, specifically the part of it that begins at index 1 and ends before index 3. So again, very, very important thing about slice. It does include this index. It does not include the end index. Okay, great. So that's slice. I guess we should probably talk about another built-in, which I don't think we've actually talked about yet, which is called concat. Okay, so concat stands for concatenate. And if you haven't heard that word before, to concatenate basically means to put two things together, or two or more things. But the point is, if we wanted to concatenate an array, so we could do sequence.concat, and then let's just put in a quick other array here, so 0, 1, negative 15. Okay, so just a couple extra elements. And what's concat going to do? Well, basically, it's going to take the sequence that we had originally, and it's going to give us the same thing, but now it's got 0, 1, and negative 15 also. So this is one way you can do that anyway. There are other ways you could do that. Like we've talked about the spread operator before, and you know what? I'm just going to give a name to this little array here because we want to maybe do some other stuff with it. So our R is this. So yeah, we could return sequence.concat array, R for array, and that'll work just the same as what we had before. But another way we could do it, and I guess I'll just write it here for now. Again, it's not going to run the code beneath here because after it returns, the function's over. So we could return something like this. Let's say it's an array that contains the stuff from sequence and the stuff from R. So when we run that, we should probably get the same thing as we were getting before. Oh, but there's a problem here. Now we have an array containing two arrays. We have sequence, comma, R. Okay, so that's not really exactly what we want. So this is where we'll use the spread operator. We'll spread these out, and we'll spread these out as well, and we'll run the tests on that. And what we'll find is now it's looking like what we want. Just to give you one maybe more illustrative example, if we were to not put the spread operator on the array R, then basically it's going to stay as an array. That's the main difference. That's what's happening with the spread operator. Now, in terms of which is better, like this method here versus this method here, I'm not really sure. I don't know if there is an advantage or disadvantage to either of these things. I'm also not really sure which one I'd be more inclined to use. I don't know, lately I've been using more spread operator, but if anyone has any insights on that, if there is, like a computation time issue that makes one of these better, then definitely feel free to let me know. I'd love to hear it. Okay, so going back to this, we've got sequence, we've got R, but what are we really trying to do here? We're trying to sort of chop up sequence and take out one of the elements. So one way we could do that is we'll use something like concat or these spreads, and we'll also use slice, like what we saw before. So we could say something like this. We could say sequence.slice, and then we'll say 0 to, I guess I'll say I for now. And what's I? Well, let's define it up here. So variable I is assigned the value of, let's just go with 2 for now. So this is going to represent the index where I want to remove the element. So if I run this now, it should give us an array that contains everything up to element with index 2. Okay, so just the 1 and the 3 here because this is the one with index 2. It also happens to be 2, but that won't always be the case. Okay, that's 2 also. All right, great example. So 1, 2, this one had index 2, so it's removing that. The thing is, we don't want to remove we don't want to remove this element and everything after it. So we want to basically concatenate to this the stuff that comes after. So we could say something like sequence.slice. Well, actually, we'll do this one step at a time. So I'm going to say var left part is assigned the value of this right here, so this thing that we just got, and then we'll say var right part is going to be sequence.slice, and basically we don't want to include the element at index I, so I'm going to start at I plus 1, and I'm going to end at the end of the array. So we could toss something at the end of this that's just like a very, very large number, and that would work, but since in doing that, we actually could just leave it without a second argument. And basically the way slice works is if it sees that there's no second argument there, it's just going to assume that you meant for it to go to the end of the array. So that's kind of a nice behavior. Okay, so let's just see what the right part is actually giving us. Great, it's the 1 here. It's the stuff after the element at index 2. Okay, so that's good. That's sort of what we want from the right part, from the left part. Is there like a really long one here? Okay, this is a bit longer anyway. So for 2, great, that's what we want. Now we basically want to do left part dot concat right part, and that should basically give us, yeah, great. So it's the same sequence, but it's now now it doesn't have the 2 there, and yeah, again, doesn't have the 2. It shouldn't have the 1 in this case. Excellent. So that's working the way we want it to. It's removing a 10 from that one, and we could use this. Well, first of all, just to give you an alternative, again, like we saw a minute ago, we could use the concat method, or we could use just the spread operator method, which is hard to say. I don't know which one is. I'm trying to think like what would be more clear to the reader. I think this is kind of interesting because it basically shows, well, it's this array and this array's elements within a larger array. But then again, maybe if you don't know the spread operator, that's not going to make a whole lot of sense. Whereas concat, I don't know. If you don't know the word concatenate, that wouldn't make a lot of sense. So it's kind of tough. I don't know which one is better. But the point is, they both do the same thing. So it's up to you. I don't know. If anyone has a preference here, we can use that. But I guess for now, we'll just use the spread operator. Or, I don't know. Okay, look. We've used the spread operator before. So for now, we'll use the concat one, just because it's kind of new. Fresh. Okay, great. So this is where we're basically saying I is assigned the value of 2. And again, we could change this. We make it 1, for example, and then we find now we're taking out the 3, or whatever the second element's going to be. It happens to be 3 there as well. We'll take out the 2. We get 1, 1, 2. Okay, so that's working the way we want to for any index I. So I might as well just take this code over here, grab that, get rid of all this stuff, and then actually put it into our loop here, because we already have something called I within the loop. And the only problem is we don't want to return this, because that'll end the whole function. So instead, we'll console log this, and that's just going to allow us to see this stuff without actually having to stop the function. Okay, great. So that looks good, right? That's what we're looking for. Take out the 1. Whoops. Take out the 1, and we're left with 3, 2, 1. Take out the 3, we're left with 1, 2, 1. Take out the 2, we're left with 1, 3, 1. Take out the 1, we're left with 1, 3, 2. Great. So that's working exactly the way we want it to. And okay, that works. That's getting the job done. It's going through all these things. What should we look at next? We've got all of our parts here. In fact, instead of just console logging this, let's say var subsequence. Am I spelling? Yeah, subsequence is assigned the value of this thing. Okay, and all right, we might as well get into this habit here. Since we don't need these things outside of the actual loop here, we might as well just make these all lets so that they're all block scope. That's a little nicer. Okay, great. So we've got our subsequence there. Then the question is, okay, let's get this comment in the right place. This is describing what we're doing right here. And we want to check if it's strictly increasing. Actually, both of these should sort of belong in the loop there. Great. So check if it's strictly increasing. Well, how are we going to do that? I think probably the simplest way to do that would just be to write a function that's going to check that, just so that we don't have to keep everything in the loop over here. So let's write a function that's just going to check if something's strictly increasing. Is increasing, we could call it. Might as well spell it with an S, actually. There we go. And this is a function that we actually do want it to have an input here. We want the argument to be an array, so I'll just use the sort of conventional ARR for array. Or I guess, we call it array, we call it sequence, like SEQ or something like that, but let's just go with R for now. Okay, so basically, what does it mean for something to be strictly increasing? Well, it means that as you go from left to right, it's always going up. It never dips like this, and it never stays at the same level like this. So basically, one way we could check that is we could just loop, go from left to right, and just check, is it ever decreasing? Is it ever staying the same? And if it is, if that ever does happen, we'll return false. So we'll say for var I send value 0, I is less than array.length, I plus plus, standard for loop here. And we'll say if array at I plus 1 is less than or equal to array at I. So in other words, if the next element is going to be less than or equal to the current element, well, that is the circumstance under which we want to return false. That means it's not strictly increasing. But if that never happens, if it never gets tripped up on that, then we're just going to return true. Okay, so let's see if this is working. So is increasing. Let's just test it with a quick test array. So it would be one that is strictly increasing. Well, 1, 2, 3, 4. Let's try that. Hopefully that should return true. It is returning true. Great. 1, 3, 5, 4. Is that going to be returning true? No, that's going to be returning false. Okay, excellent. So then one last thing I wanted to say about this. There's since we're checking I plus 1 here, well, we probably shouldn't make I go all the way to the end, because if I is going to be equal to array.length minus 1, then when we add the plus 1, it's going to be array.length. We'd actually be going out of bounds. So since we're just making comparisons, we're saying, hey, is the next one below or equal to this one? No? Okay. Is the next one below? Basically, the last one we need to make, the last comparison we need to make is this. So we're comparing this one to this one. So that's not actually the last element, it's the second last element. So let's fix that. Let's just make it a -1 for now. Okay. Great, so that's false, and I mean I think this is probably still working the same way, but let's just put it to the test. That should also be false. Excellent. Okay, so increasing is working the way we want it to, and we can just keep this right here. I mean, we're going to use it, we're going to reference it down here, so that's going to make this part very easy. So is it strictly increasing? And if so, return true. I'm going to make that one comment because it's just going to be one line here. We're just going to say if is increasing with an input of subsequence. So if the subsequence is increasing, then we can return true. And keep in mind, this return is not like the return up here, or the return here. These returns had to do with this function is increasing, because this is a function within a function. It's a nested function here. Whereas over here, when we're talking about this return, that's not inside of another function. I mean, we talked about sort of the let here, the scope of the for loop, but it's not a function. So return is going to look for basically the most internally nested function that this line is within, and in this case it happens to be almost increasing sequence. Alright, so basically when we return this, that means this function's done. It's not going to keep going after that. It's just going to return true and nothing else. It's not going to keep looping or do anything else after that. Okay, so then really the only thing we need to do at this point is we need to say, well, if you didn't find one, return false. And the only circumstance under which we'd actually make it to this line here is if it never actually triggers a return. So in other words, if we never find a strictly increasing subsequence. Alright, let's just clean this up a little bit and we'll take a look. We'll run the tests on this. We'll see if it's working or if it has any errors or anything like that. Oh, look at that. It is passing all the sample tests. Oh, wow, there's a lot of sample tests. Okay, so great. That's a lot of check marks. That feels pretty good, I have to say. Alright, so then we probably want to submit this. You know, it's looking pretty nice. It's looking not bad. We've got this nice function over here. Maybe we could clean it up a little. You know, we could say something like put a let in here. I'm not quite as concerned with this one because the thing is, like whether it's a let or a var here, it's not going to exist outside of the scope of this function anyway. So it's not as big of a deal, but you know, it's one of those things we probably want to get in the habit of. Alright, so is there anything else that we can improve here? Well, yeah, there is. There's one thing. Basically this right here. So we've got a lot happening, you know. We're making a new copy of the sequence array. We're making another copy of it over here. And then we're doing a concatenate. Maybe there's a more efficient way that we can do that. And spoiler alert, yeah, there is a more efficient way we can do that. And it's using the splice method. So I want to talk about splice for a little bit here. I'm just going to, again, make some room. And we're just going to do a bit of an activity with splice. Okay, so we're going to make a new array over here. It's going to be 7, -12, 0, 9, 5. Okay, great. And we want to return R for now, just the array. Okay, great. And now I want to do something a little bit different here. So I'm going to do array.splice now that we know that this is working and it's returning the array just fine. So we're going to do a splice on this, and let's see. We'll try to do something a bit like slice. So I think the arguments I used for slice were 1 and 3. We'll use the same arguments right now, and that's kind of different. That's kind of not. Well, it's definitely not the same as slice. If you think about the way slice would have done this, slice would have taken the elements beginning at index 1 and ending less than index 3. So we should, from slice, we'd expect -12 and 0. With splice, we're getting -12, 0, and 9. Okay, so this is an important difference for splice. When we're talking about splice, it's not the start index and the end index. It's the start index and how many elements you want. So since there's a 3 here, we're getting these 3 elements down there. If I were to make this, let's say, a 2, now I would be getting 2 elements, just the -12 and the 0. Let's say I wanted to make it 7, for example. Let's see what's going to happen here. Well, basically, it's going to say, well, I couldn't find 7 things, but I took as many as I could. I'll give you the 4 here. So just like slice, it's sort of doing the best that it can. Now, it might not seem all that different than slice at this point, but there's something interesting about this one that I sort of want to show. So I'm going to switch this back to, we'll say 2 elements. So it's going to be taking away 2 elements from the array. Right, the -12 and 0. Great. But now instead of returning this, I want to just return the array itself. And take a look at this. This is a bit different from slice behavior. I mean, just to sort of give you a comparison, if we were making this a slice, well, this isn't affecting the array. I mean, we're sort of making a new copy with this thing, but the array is staying intact. So returning array is just returning the same thing that we had before. But if we make this a splice, then it behaves differently. So splice is a morphing or destructive function. It actually does change the elements in the array. It actually will alter it. And also, it returns its own thing as well. So just like slice returns the subarray, splice returns the part you're removing, and then it keeps the part that you didn't remove. So basically, the idea is when we do .splice 1, 2, it's saying, okay, we're going to take this part, we're going to remove that from the array. So the array after this is just going to be 7, 9, 5, which we can see it is. And then the -12, 0 will return that as a result of this. So we could say something like var removed is this over here. And then what remains is going to be r. What's been removed is going to be, well, this one, removed. Okay, so that's an important distinction between slice and splice. And something we talked a little bit about when we were doing sort, the array built-in .sort. Okay, so that's how splice is going to work. Now, like I said, we've got the start index, we've got the number of elements that we want to remove. There's other stuff we could do as well. We could build in a third argument here, and let's just say I'm going to make it 8. What does this represent? Well, as you can see, it's taking out the -12 and 0, so it's, well, let's do this one step at a time. So splice, first argument says the starting index. So we're starting at index 1, 0, 1. So that's 1 there. And it's taking 2 elements out. So we're going to remove -12 and 0. So we should expect from that something like 7 and then 9, 5. But notice this 8 here. This is just an element that it's going to slip in the place of what it removes. So it's going to take out -12, 0. It's going to replace it with 8. Okay, so basically, that's if you want to kind of replace part of an array with another part. But the main thing is I'm not that interested in replacing it. I basically just, well, we want to remove one element, so I'm going to switch this to a 1. Which element do we want to remove? Well, that kind of depends. I mean, we could say for the first time through, we want to remove the first element. For the second time, we want to remove the second element. Or sorry, I should have said the 0th in the first. But anyway, the point is, this is going to be kind of like our I. Hey, it's the thing that's going to change in the loop downstairs. So let's get that back in action. Let's just take this .splice part of this, because that's sort of the useful part. And we're going to get rid of all this stuff. Okay, so few things to note here. First of all, well, we don't need any of this anymore. I'll keep it there, maybe comment it out for now, just so that we can sort of see it for comparison, but I don't want it to actually execute that stuff. So we're going to say sequence, and then this, .splice, and I1. So it's going to take that sequence, it's going to splice it, so it's going to take out the ith element, and just that one. Okay, great. Now we could do something like this, like subsequence is assigned the value of sequence.splice. But the problem with that is then subsequence would just be the one element that it's removing, which is not what we want. What we want is to actually modify sequence. So let's see if this is working. And actually, let's just do a little console log down here on sequence and see what's happening to sequence. So let's run this and we'll see what happens. Oh, subsequence is not defined. Okay, so maybe let's just comment that out since we don't have subsequence anymore. Okay, so there's kind of an issue with this. So check it out. We're just getting 3, 2, 1, and then just 3, 1. Okay, so the problem here is we don't actually have subsequence right now. We need to actually make a copy of sequence. So we could say something like var subsequence. I have a lot of trouble with that word apparently. Okay, subsequence is assign the value of sequence. We'll just make a copy of it, right? And then we'll make this subsequence.splice, and then this part should work, and we'll do subsequence over there, and everything should be fine now, right? Oh, that's weird. Okay, so we're looking at this one, 1, 1, 2, 3, and in terms of how it's going through and getting these subsequences, it gets 1, 1, 2, 3, then 1, 2, 3. So this is still not quite working the way we want it to, and the problem is, well, it's something we've seen before. We need to make a deep copy of sequence. This is still referencing the same array. So basically, sequence is saying, for example, in this first case, it's saying sequence is this thing. Sequence is that array. When you see sequence written here, it's actually talking about this thing. And then subsequence is saying subsequence is on the value of sequence. Well, that basically just means point to the same thing in memory. So now subsequence is also pointing to this array. When this array changes, it's changing subsequence and it's changing sequence. So instead, we want to make a deep copy. We want to do a dot slice with no arguments because that's the way we're actually going to copy it. So let's run that now. And, oh yeah, it's passing all the sample tests. If we look at it, it's properly getting all of our subsequences in here. So this is good. And if we take a look at it, I mean, we've got these 2 lines here. We could compare that to these 3 lines over here. And I guess just for consistency, I'll put another let in there. So that's pretty not bad. Hey, shouldn't that be blue? Yeah, there it is. Okay. All right. So we're saving 1 line. In terms of computation time, I don't know. They seem comparable to me. If anyone knows if one of these is better, feel free to let me know. But just in terms of convenience, I think, look, we've got a built-in called splice. We might as well use it, right? I mean, this is what it's intended to be used for, or at least this is one of the intended uses. So, okay. This, is this running? Is this giving us all the answers? Oh, yeah, it is. Okay, so sample test passed. That's a good feeling. So, I don't know. We've got some nice comments in here. It looks like the code sort of speaks for itself. We're using these nice block scoping declare statements here. So I guess we can go ahead and submit this. I guess that pretty much wraps it up. We got all the check marks, so that's what we were looking for. Oh no! Look at this. Okay, so we made it through 33 of these tests, but there's something going on with that very, very last one. So what's going on with that? Well, let's look into this. Anytime we get this execution time limit exceeded error, no, first of all, first thing I want to say is that's different from it saying you got the wrong answer, or like, some of the tests didn't. I don't know the wording of it, but the main thing is if it says you got the wrong answer, that just means, well, your code didn't. Yeah, it wasn't right for all of them. And in this case, it's saying time limit exceeded. So that's a bit different. That doesn't mean that the code is working fine. It just didn't get the right answer. That means the code had a problem. The code timed out. It became too. The computation time was it was too much. So basically, anytime you see this, that it's a good indication that we should sort of check out our guaranteed constraints here. So there are a couple of guaranteed constraints. This one is the length of the sequence. This one is the elements inside the sequence. So the length of the sequence, look at this. From 2 to 10 to the power 5. 10 to the power 5. That's 100,000. That's a huge number of elements. So probably that means test 34 is something that has about 100,000 elements in the array. The problem with that is, it's no big deal to do a quick splice here and there, but when you have to do that 100,000 times, when you need to create 100,000 new arrays in memory, well, that's not good. That's not good for the computation time. I mean, that's pretty tough. So yeah, ATD, we were so close, but yet so far. So you know what? We're going to have to rethink our entire strategy here. I think we're literally going to have to go back to the drawing board here, because what we found is that our way of thinking about the problem wasn't good enough. If we think about our computation time here, it was too heavy. I mean, we're going through this for loop. Every time we go through that for loop, we need to make a new sequence. Think of this as equivalent to sort of looping through the array. In fact, it's probably worse than that. Then we need to check if it's increasing, which also loops through the array. So we've got, at the very, very least, we've got a quadratic kind of complexity happening here. It might be even worse than that. Anyway, the point is, that's not good enough. I mean, if you remember our big O cheat sheet here, n squared, that's horrible. It's in the horrible zone. We want to be in the excellent zone. Now, I can't guarantee we'll be able to get to the excellent zone for this particular problem. It's not always possible, but let's give it a try. We're going to rethink our algorithm. We're going to think about what's the best way to go through this. So, something to notice here is, well, this on the left is an example of something that should work, something that should return true. And the way we're doing it now is basically we're saying, okay, what does the sequence look like without this element? Is it increasing? No. Okay, what does it look like without the next element? Is it increasing? No. Okay, etc., etc., right? We're doing that until we find one that actually does work as a strictly increasing sequence. That's very inefficient. Maybe there's a way we could do it by just kind of traveling through the array one time. So let's look for some patterns here. If we look at this one, we kind of notice, well, it's strictly increasing, and then it's not, then it drops. But then after that, it's strictly increasing again. Okay, so that's kind of a useful way of looking at it, or maybe it's going to be a useful way of looking at it. Let's see. So if this is enough, then we could just sort of say, for example, we could iterate through the array from the left and go as far as we can until it's no longer increasing. So as soon as we see that the next element is going to be a drop-off, we would stop it here. So we would say that is going to be the element that we're going to end up at for our left iterator. And then we'll do a right iterator as well. We're going to go from the right, and we're going to go down until we're no longer decreasing. So basically, starting from the right, strictly decreasing, strictly decreasing, strictly decreasing, and then that's increasing, so we'll stop at this element. So that's where R is going to end up. So basically, if L and R are kind of right next to each other, then that should be enough, right? So we could say something like L plus 1 equals R. And keep in mind, since we're talking about Boolean logic here, it's got to be equals equals. It's not that L plus 1 is assigned the value of R, it's that they are equal to each other. Okay, great. Now, just to sort of test this, see if it actually will not work for the one on the right here, well, let's see. So we'll go from the left. We'll stop iterating as soon as it's no longer increasing. But if you think about it, it doesn't increase from the very beginning. So we're just going to make this one left. That's our left iterator. It stops there just as soon as it started. And the right iterator starts here, decrease, decrease, decrease. So this one would stop over here. Okay, so are the left iterator and the right iterator right next to each other? Of course not. So this statement here would fail, and therefore it would be false. L plus 1 is not equal to R in this case, or left and right. I'm just using an L and an R here because it's kind of hard to write with a mouse. Anyway, the point is, this is going to sort of be our new game plan for this thing. So we're going to start left at the very left, the leftmost point. So we're going to start at 0 for left. And then for right, we're going to start at the rightmost point, which is going to be the sequence length minus 1. So I've already used L for left, so I've got to spell out length here. Length minus 1. There we go. All right, so left is going to start at 0. Right is going to start at length minus 1. They're going to come together as much as possible. Left is going to move to the right as long as it's increasing. Right is going to move to the left until it is no longer decreasing. Okay, and then at the end, after they're done their thing, we'll make this comparison and we'll see if they made it close enough to each other to be able to actually say, yeah, that's a strictly increasing sequence of one element. Okay, great. So we'll go back to this and we'll comment this out in our typical style. And maybe we'll make a little bit of a comment about this. So we'll say this was big O of n squared at least, and then we'll say horrible didn't pass hidden tests. Okay, great. So word of caution to whoever takes a look at this next. And you know what? This thing, that could be misleading. That's actually a bitwise operator in JavaScript. So we'll just use this notation that we looked at before for exponentiation, which is a really nice notation. I mean, we used to have to use math.pow. So I don't want to get too in-depth about that. We have some code to write. So we're going to say var, or let's just go right for the let, right for the ES6 declarations. Might as well, right? Okay, so we're going to let left be assigned the value of 0. We're going to let right be assigned the value of sequence.length minus 1. And then we're going to do some loops here. So I'm going to use, I could use a for loop. I could say something like for, but I don't really have anything to declare here. I suppose I could put the left thing in there, but I don't know. And then, well, actually, what am I checking? Well, left is less than right, and then left plus plus. We could do something like that. I mean, it's sort of up to you. But I'm going to use a while loop because I don't really like the look of a for loop where we're leaving something blank like that. So I'm going to say while, and we're just going to say while left is less than right. Okay. So that should go all the way from the left of the sequence all the way to the right of the sequence, because remember, right is sequence.length minus 1. Okay, so then we've also got to be able to say, well, if it does encounter a situation where it's no longer increasing, we should probably break out of the loop there. So we could do something like this. We can say if sequence at left. So left is just like, it's our iterator. We're using it kind of like we were using I down here. Okay, so sequence at left, if that is going to be, if sequence at left is greater than or equal to sequence at left plus 1. So basically, if the element that we're at right now is greater than or equal to the next element, well, we should stop. We should break out of the loop. And if we haven't talked about it yet, the keyword we use for that is literally break. So break means we're going to stop the loop right there. We're not going to continue at all. We're not going to do any more iterations. There's also another keyword called continue, which is very similar. It basically says, well, don't execute any of the stuff down here in the rest of the loop, but just move on to the next iteration after that. So we don't want to continue. We want to break. And we also don't want much other stuff in the loop here, but we do need something else, because otherwise this is probably going to go on forever, because look, left isn't changing. Left is 0. We haven't changed it. So we do actually want to put in a left plus plus, or a left is assigned the value of left plus 1, left plus equals 1, however you want to, whatever syntax you want to use. But the main thing is we're going to increase left. We're going to start at 0. We're going to increase it until we either get to the end or until we get to a point where it's no longer increasing. So maybe I'll make a comment. So iterate left until the sequence is no longer increasing. Okay, there we go. So that's nice. That's going to give us our left value, and let's just say return left at this point, just to see if that's kind of working the way we're expecting it to. So this one, it's stopping at 1. Does that make sense? Well, from 1 to 3, it's going up. From 3 to 2, oh, well, that would be going down. So yeah, it should stop at the element with index 1. So that's good. This one is also returning 1. I mean, it's the same sort of thing. This one also 1, because it would have to go down from 2 to 1. This one's 0, because from 10 to 0, that's already a drop. What about this over here? Also 0. Okay, and you could say, well, that one is not going down, but it's not going up. And that's the main point. We need for it to be strictly increasing. Okay, I want to find one that's not like a 0 or a 1. That's a good one. So this one, 1, 2, 3, 4, 5, 3. So basically this, everything up to including this one, it was fine. It was good. It was working the way we wanted to. It goes all the way up to 5, but then it drops, and that's the problem. So basically, 4 is what we want to return, because remember, this is index 4. Even though it's technically the 5th element in the array, it has an index of 4. Okay, great. So index is 4. We want to return 4. You know what? I think left is working the way we want it to work. Okay, so before we go any further here, I want to address a potential situation here. I want to say, well, if left made it all the way to right, then we actually want to return true. And the reason we want to do that is because if left made it all the way to the right, if left, got all the way up here without encountering a situation where it was decreasing, well, that means that the sequence was strictly increasing to begin with, because it never encountered a situation where it wasn't strictly increasing. So if it makes it all the way to the right, then yeah, return true. Go for it. I mean, we have enough information to say. Oh, and by the way, here's another thing. Notice we had declared left outside of the loop. We already have left. We're declaring it outside here, and that's why we're able to talk about left down here. As opposed to like we were doing over here where we did these for loops with a let in them. If we had done that up here, if we had done a for loop and say let left based on the value of 0, then we wouldn't be able to access it outside of the while loop. We wouldn't be able to do this down here. So it's probably better that we did it this way. Again, it's not the only way to do it, but it's probably better. Anyway, okay, we've made it this far. Let's continue. So we know that if the left makes it to the right, we're going to return true. And if we were to run this right now, we would probably find that it would be right in a few cases. Wow, I was totally wrong about this. It was wrong in every single case. We didn't get a single return true. So I guess that means there isn't one that's strictly increasing to begin with. Let's just use this as an example. This one is strictly increasing to begin with. We should expect an output of true. Oh, and by the way, custom tests are a really excellent tool here on codefights. Like I said, I mean, look, if you're in the real world, you're making an app or a website or something like that, you're trying to troubleshoot some code that's not working the way you expect it to, you're going to have to do all these tests yourself. You're not going to have any predefined tests. So like I said, it's generous that they give us all these visible tests. When I see people asking for the hidden test too, it's like, don't be greedy. Anyway, the point is, so we've got our custom test. This is one that should return true because it's strictly increasing to begin with, and that's really the only circumstance under which we're actually returning something, let alone true. Let's run this test, and boom, we're getting true. Okay, so that's nice. That's at least telling us that it's working the way we want it to be working. But we're not done with our code yet, because all we've done is this part here. All we've done is the left part. We haven't done the right part yet, so let's do that. So we're going to do a while loop, just like we did before. We're going to say while right is greater than or equal to 0. And I should probably use the greater than symbol for that. You know what? I think I'm on a French keyboard. Yep, I got switched to Canadian French. Okay, if anyone knows how that happens, like obviously there's some kind of keyboard shortcut to switch your keyboard, and I keep hitting it accidentally, so I get, accent aigus instead of question marks and stuff like that. So if anyone knows how to switch those, I'd be happy to hear it. Anyway, okay, so we're going to say while right is greater than or equal to 0. By the way, if you're wondering why it's greater than or equal to 0, well, 0 is a possible index here, so we wanted to maybe check that as well. Okay, so, but now that I think about it, if we're already checking to see if the whole thing is strictly increasing, we probably don't need the equal to 0 here. Maybe we'll keep it for now, and well, actually, you know what? Maybe we'll get rid of it for now, and then if it doesn't work, we'll adjust course. So we'll say, if, and it's going to be something very similar to this one over here. So this one was basically saying we want to iterate left until the sequence is no longer increasing. In this case, we want to say iterate or de-iterate. Is that a word? I don't know. De-iterate. I want it to go down is what I'm trying to say. But de-iterate right until the sequence is no longer decreasing, because we're going from the right, we should expect it to decrease. So we'll do something like this. We'll say sequence at right minus 1 is greater than or equal to sequence at right. Okay, and what should we do if that ends up being the case? We should break right out of this loop. And again, since we don't want the loop to go infinitely, we should probably iterate right, and that should be fine, right? Let's try it. Actually, I'm not really returning anything after this, so I don't know if this is... Oh, look at that. Execution time limit exceeded. Well, we saw that before, and we found that usually that means it's it's taking too much time. And that might even mean that we've got an infinite loop, which happens to be the case here. Because notice, I said before, I want right to go down. I want it to go further to the left. I'm telling it to go up, so I don't want a plus plus, I want a minus minus. So keep that in mind, just like plus plus means, assign it its current value plus another 1. This one is saying assign it its current value minus another 1. Okay, so that's a nice useful tool. All right, we've got right, we've got left. Both of these are working. All we really need to check now is this last little bit of info here. Is left plus 1 equal to right? And let's see. So we could say if left plus 1 equals right, then return true. Okay. But before I run that, I just want to point something out. I do sort of have a beef with this kind of notation. I've mentioned it before. The issue is that this is a Boolean. This thing inside the parentheses here is a Boolean. It's something that's going to be a true or false value anyway, right? And the only circumstance under which we would return true is if this thing right here is already true. But if this is already true, then why are you saying return true? We don't need another true there, so let's just return this thing. Let's just return that Boolean. So return left plus 1 equals right. And that's kind of a strange, like, just looking at the notation here, is it semantic? Maybe not, but basically the idea is it's returning whether or not left plus 1 is equal to right. So it should just give us a true or a false. Let's run this and we'll see if it's working. Okay, so at least one of them didn't work, but let's see how many did. I see a lot of check marks, 14 out of 17. So this is covering most of the bases here. It's not timing out. It's not having any issues. Aside from being wrong in 3 cases. So maybe we'll go through and we'll take a look at those 3 cases, but this is pretty good, right? I mean, if we take a look at what it's doing, it's only iterating through the array one time. We didn't do any slices, we didn't do any splices, we're not making copies of the array, we're not increasing the memory that's being taken up for this problem. So we're doing pretty good, I'd say. All right, so then switching over to this again. Actually, let's use a concrete example here. Let's go back down to this one that wasn't working. So this is 1, 2, 1, 2. Why was this one not working? Let's take a look. So I'm just gonna clear this area. So we got a little close over there, but let's see. Okay, that's pretty not bad. Let's just get an eraser for the finer details. And there we go. Okay, that's probably good enough. And you know what? We don't know if it's going to be true or false, so let's just erase that for now. Okay, great. So I think I was using something like this size. We'll see. 1, 2, 1, 2, right? Is that what it was? Yeah, 1, 2, 1, 2. Okay, so we'll do 1, 2, 1, 2. Okay, so those are maybe not exact, but we'll pretend they're at the exact same height. And we'll take a look at what's happening here. So we'll just run through it as though we are the computer. So we'll say, well, left, it starts over here, and it's going to go up until it's no longer increasing. So this is where L will end up. And then right is going to go down until it's no longer decreasing. So this is where right should end up for 1, 2, 1, 2. So wait a second. Isn't L plus 1 equal to R here? Shouldn't that be the case? I mean, shouldn't this return true? Well, yeah, it is returning true. That's the problem. It should return false. Well, why should it return false? Maybe I'm not convinced. Let's do a bunch of undos here and just get the sequence itself. Well, let's sort of go through this one the way we were looking at it originally. Let's say, okay, remove one element at a time. So remove that one. Is that a strictly increasing sequence? No, it decreases as its first move. Okay, we'll remove this one. Is this strictly increasing? No, not strictly increasing because this one stays the same for its first move. Okay, so that's no good. Let's remove this one. Well, now it does increase, but then it stays the same again. So that's no good. Let's remove this last one. No, it goes up, but then it decreases. So that's no good. This one really should return false. We want a false here. But when we ran through it, we found that L was going all the way up to this element, and we found that R was going all the way down to this element. So it did satisfy this over here. So what's the problem here? Well, I guess the problem is that even if we remove either L or R, it's still not going to work. So if we compare some of our other elements here, I feel like we don't use brown enough. Let's get some brown in here. Okay, nice. So Okay, what needs to be true here? Well, let's take a look at this. Let's take a closer look. The reason this one worked is because if we were to remove this element here, then the remaining nodes, the remaining elements, are still increasing. So basically, in this case, left, or sequence at left, was less than sequence at right plus 1. Okay, sequence at left was less than, strictly less than sequence at right plus 1, the one after right. Okay, so let's get that. Sequence at left is strictly less than sequence at right plus 1. And I'll just say or. Okay, so hold on a sec. Let me get this in first before I forget it. Strictly less than sequence at right plus 1. That's what it was, right? Okay, sequence at left is strictly less than, and okay, I should probably talk about this or thing. Basically, that's just like the word or in real life, in real logic. Basically, if this is true or if this is true, then this whole thing will be true. It'll return true in that case. If they're both true, then it'll definitely return true. But if none of them are true, if neither of them are true, that's the only circumstance under which this thing would actually return false. So we're basically saying, yeah, we want this. Well, actually, it's not that we want that or we want this. We want both of those to be true. We want the left plus 1 to be equal to the right, and we want also this additional property where sequence at left is strictly less than sequence at right plus 1. Because otherwise, there could just be, it could be like this, right? Where basically where it's not increasing. So if we look at left versus right plus 1 over here, it's not going up. It's just staying lateral. Okay, so we want this and we want this. Okay, great. So let's run that and we'll see if that works. Oh, I guess I should probably say, okay, hold on a sec. We'll return to that one. I guess I should probably say here, when we're talking about and, the way that's going to work is if this is true and this one is false, then they're not both true, so the whole thing would return false. And likewise, if this one was false and this one was true. If they're both true, then this thing will return true. And in fact, that's the only circumstance under which it'll return true. If they're both false, then definitely they're not both true, so it'll return false. Okay, so what's happening now? First of all, if I look at my 1, 2, 1, 2, what's giving us the false that we were looking for? So that's good. We fixed that issue. But I think we were passing 14 out of 17 before. Now we're only passing 10. So we kind of took a step back in that sense. So now this one's returning false. Why is that? 1, 3, 2. Let's get that on the boards here. So let's go back a billion times. And it was 1, 3, 2, I think, right? So 1, 3, 2. There's 1. There's 3. There's 2. Is that right? Yeah, 1, 3, 2. Okay, so how's it going to run through this one? Well, first it's going to start increasing. It's going to get to this point, so left will be index 1. And then right, well, it's not decreasing at all, so right's going to end up over here. Okay, so why was this one having a problem? This one should return true, by the way. I mean, it's fairly clear that if we remove either this element or this element, we'll have something that's strictly increasing. So we should get true, but we are getting false. And the reason is because we're saying, well, this needs to be true, and it is. It's passing that part. So it must be failing this part over here. The sequence at left is less than sequence at right plus 1. Why would it be failing that? Well, maybe because there's no right plus 1. There isn't a next element over here. So we sort of want to check for that as well. So basically, if right can't go any further, well, okay, we'll make an exception. So we'll say for this part, just for this part over here, because for all of this, we need for this to be true, for sure. That's never going to be untrue. But for this stuff, basically, we're going to have options. So we're going to say, or right is equal to sequence dot length minus 1. Like it's already right at the end. In fact, you know what? I kind of want to put that first. So I want to put that here just because, I don't know, I kind of feel like it should be checking that before it actually executes this right plus 1 thing. So if it's at the end, if right is already at the end of the sequence, we're saying, well, in that case, yeah, that's fine. We don't need to worry about what comes next because there's nothing next. So this can be the final element if we cut this one out. And in that case, well, that's fine. Nothing wrong with that. So we don't need to worry about it if right is already at the end. And keep in mind, since this has to be true, like I want to be clear about this. In JavaScript, if this ends up being false, then in terms of the way it's going to execute this, in terms of the way it's going to actually read the code, it's going to say, well, this is false. No matter what this is, all this other stuff over here, it could be true, it could be false. It doesn't matter. If this part's false, the whole thing's false because they both need to be true for an AND statement to be true. So basically, JavaScript is nice like that. It basically says, well, if that's not true, I'm not going to go any further. I'm not going to waste my time checking this stuff over here. So basically, that means if we've entered these parentheses here, if we're getting into these statements, then we already know that left plus 1 is equal to right, or equivalently left is equal to right minus 1. So basically, how does that relate to this? Well, it means if right is at the end of the sequence and left is just behind it, then that means left has made it all the way to the end of the sequence minus 1. It's the second last element. Okay, and it was strictly increasing all the way up to there, so that should be fine. So if we run the test, I'm expecting it to pass at least more than 10 this time. Okay, great, 13. So we're almost back to that 14 that we had a minute ago. So we've got a couple other situations here. We've got this one. What else? We've got this one. Let's look at this one. It's not so many elements, and it's kind of a good example. 1, 2, 5, 3, 5. So let's get that in here. I'll just undo all these again. Okay, great. So this size, and there we go. So what was it again? 1, 2, 5, 3, 5. Okay, 1, 2, 5, 3, 5. Okay, that's probably not quite at the right height, but we'll pretend it is. All right, so we're going to go from the left as far as we can. So there we go with L, that's our left iterator. And from the right, we go down here, and that's where our right iterator is going to end up. Okay, so again, it's passing this thing, which means it passes this. We will consider the stuff in the parentheses. So maybe we're going to have to add some other condition to the parentheses there. Let's see what that condition is going to be. So in this case, what have we checked so far? So left needs to be less, a sequence at left needs to be less than sequence at right plus 1. Well, is that true here? Actually, no, it's not, because sequence at right plus 1 is the same as sequence at left here. So that's no good. That's not going to work. But then again, this should pass, right? Because if we remove this, this 5 here, then it should be a strictly increasing sequence. Okay, so basically we've got to look at it from a different point of view. We'll say in this case, we sort of want to compare this one over here to this one. This is what we're comparing now. So it's not right plus 1, it's left minus 1. So if sequence at left minus 1 is less than sequence at right, then all should be fine. Okay, so we'll put in another OR, and you know what, at this point, it's just getting kind of cluttered in here. I don't like the look of this, so I'm gonna put these on new lines. This isn't going to affect the code in terms of how it executes or anything like that. It's just going to make it a little, just a bit nicer to look at, I'd say. Okay, so, all right, great. What we wanted to say is sequence at left minus 1 is less than sequence at right. Okay, is that going to work? I forget what test that was. Test 5 or something? We'll see. Okay, test. Oh no, it wasn't test 5. Was it test 7? Or it wasn't that one. But these are all passing, which is good. Oh, it was this one. Okay, so it's test 11. 1, 2, 5, 3. It's true. Okay, so that's great. We're getting the right answer for that one. But ooh, we're missing 2 still. So we're getting real close. We're getting real close. Which 2 are we missing? Okay, that one's pretty big. I was hoping it was going to be shorter than this one, but that's fine. So this one's 10, and that's 1, 2, 3, 4, 5. Okay, well, we can sort of see what's happening here already. We're encountering an issue that we kind of already saw in the other direction, so to speak. So we have 10, and then 1, 2, 3, 4, 5, I think it was. Anyway, something like this. The main thing is, check it out. This is the one that we should be removing. I didn't mean to make that so thick. Sorry about that. This is the one we should be removing. And if we go down here, R will make it all the way to this. So again, it's passing this. But the problem is that there's no left -1 here. So basically, just like we had to check if right was all the way at the rightmost end, we also need to check if left is already at the leftmost end. So we're just going to do another one of these, and we'll say left equals 0. So under that circumstance, it should let it slide. So let's run that, and we'll, oh yeah, that's what we're looking for. So we see check marks everywhere. This is our good code here. It seems like it's working. Now, I'm hoping this is going to pass all the tests here, but we'll find out. So first, let's just make a bit of a comment here. I mean, we sort of looked down here and we said, well, this is big O of n squared. What's this one going to be? Well, it's basically going to go through the array one time in total. I know there are 2 loops here, but keep in mind those loops don't overlap each other at all. Basically, left will never make it further to the right than right. Or L will never make it further to the right than R. Okay, so basically that means we're really only going through the loop one time. We're only going through the whole sequence one time. And so basically this would be sort of like a big O of n. That's a huge, huge save. Again, we'll look at our complexity chart here. We just went from this in the horrible zone, this n squared business, all the way down to this, big O of n. I mean, that's a pretty significant change. So we're not in the excellent zone, but I don't know if we possibly could be for this particular challenge. I mean, it's not like every task could be done in big O of log n. It's not always possible, so we'll do the best that we can. Is it going to pass all the tests? Let's find out. So try submitting this one. We're happy with the way our solution looks. Oh yeah, there we go. Okay, great feeling. Hey, look, we're almost on the edge of the ocean here. I'm not going to continue. I'm just going to close this for now, and we'll just finish this up. So let's see. Is there anything we want to clean up here? Actually, you know what I'm just realizing? We're really... The big savings here, I mean, yeah, for sure, we cut down the time complexity, but the memory usage, we really, really are not using a lot of extra. I mean, look at this. We only have 2 lets. We've got 2 variables that are being held in memory. Aside from that, no extra arrays or anything like that. I mean, compared to this monstrous like slicing and splicing we were doing over here so many times, this is a lot better. Okay, so I think I feel good about this one. I don't think there's really any more changes that need to be made here, so we'll finish up with that. I'll just go back to the edge of the